Everyone, thanks for joining. Today, we're going to be talking about generating in-process KPIs from a set of related tables. So the specific business need here is we need to develop a set of intersection union metrics to help us decide where to focus process improvement initiatives. Background, of course, is that different steps of an internal process generate slightly different data sets. The challenge is that managing multiple fact tables is different than managing a simple fact dimension schema that's been organized with star snowflake. The solution is we're going to propose an approach that's been validated in a Fortune 20 company with 600 sites, 30,000 devices, and an operating 850,000 row model. So the business requirement is to automate the production and intersection of metrics from multiple fact tables. And in our case, it's going to be scan, inventory, and cost. You can see here it's 10 sites and 30 unique devices. We're going to deliver a scalable solution that's consumable on a mobile device. This is an illustrative visual of where we're going to end up in the Power BI solution. Okay, the lesson plan objectives. We're going to start with the originating data sets so we can familiarize ourselves with the presenting attributes. We're going to look at the model structure that we're going to be using to pull this together. We're going to examine the complications of the standard approach. And then we're going to look at the KPI solution, which are the intersection union metrics. And then we're going to look at an analogous but slightly different issue, which is, all right, so how do we build cost into that model to enable propagation of costs across the environment? Then we're going to look at the overall intersection schema and think about, so this is where to play and how are we going to win? Finally, we are going to illustrate the construction of those measures with DAX Studio. Finally, we're going to port everything to Power BI, and we're going to illustrate how the mobile experience is the platform of choice. Jumping into the data set here. First of all, you can see we've got three different data tables, right? Inventory, scan, and cost. They're all slightly different across a couple of different dimensions. First, they're all missing slight amounts of data. Here we've got IP addresses in the scan table, and here we've got costs in the cost table, and here we've got device types in the inventory table. And so the tables, while they're slightly different, they're all related and coming from different parts of the process. You know, the typical Excel approach, which is to use a VLOOKUP and index match types of expressions, is simply the wrong tool for the job. You know, all you've got to do is ask yourself a set of questions. You know, which of these tables should be used as the baseline? From what table are pivots going to be generated? How would intersection metrics across multiple tables get generated? And what is the approach to automate the production of those metrics? The traditional tool set simply falls apart. So we're going to move to now the model structure. And the point I want to illustrate to everyone here is you can see the presenting fact tables here essentially are cleaned and scrubbed. And what we do is we create a new index table constituted from these various facts tables. It is important, though, that we have a primary key in these originating tables that is common across those tables. And in our case, serial number is the obvious choice. That's number two. Number three, think of this index table effectively as being the pointer back into these fact tables. This solution is immensely scalable and happens to deliver n-by-n views across the data set, as we'll see here in a little bit. Beneficially, other tables, such as a data or site table, can also be connected. Finally, and most importantly, cross-data model measures are enabled via the index table. We'll illustrate how that happens. And then situated in a measure table. When we pulled this together, we did have some consulting from an individual named Dave Bauer. He today is the CTO of his data company called Lucid. At the time, he was with BT Professional Services, and he provided consulting for us on the solution. Okay, let's go look at the traditional environment here for a minute. So this is where most people end up. They're able to join the tables together. Again, we're going to take serial numbers, put them on the row side here. We're thinking we want some costs, so we'll go old, new, and CapEx, and you can see we now have a problem. The point I want to leave everyone with here from this particular slide is that absent the measures, there is really no way that traditional Excel can scale efficiently across multiple data sets. Okay, let's now move to our KPI solution. So the first point I'd like to make is the difference between explicit versus implicit measures. We saw here how the 81 is an implicit measure generated by the system versus the explicit measure here of the function that we have. We've generated a function and we're essentially counting the elements of our data table. And perhaps it'd be helpful to actually jump into this and take a look at. You can see we have our originating data sets here that we accumulated. You see this is the M code. We're essentially accumulating all of this. We union all the tables together, right? So the function that we're creating is basically lives in the data model. And so here's on our index page, you can see our 81 rows. And what we're doing with the measure is we're simply executing count rows of the index table. And so we're simply counting the number of rows of this table. This now is an explicit measure that we can use generally across the entire data model. This particular serial number, C345, is visible in scan and cost, but not visible in inventory. And you can see how the measures are capturing that. The 72 means that of the 90 total devices, right, we have 30 times 3 data sets, we have 90 total devices. We have an intersection count of 72 divided by 90, which is about 75%. We're going to take this one first to examine how this particular metric is computed in DAX Studio. We reconnect to our model. We've established a connection here. We start with an evaluate statement. We'll take one of these tables. We'll take our inventory table just as an example. We've just run our inventory table. What we see here is a high fidelity representation of what is in that inventory table. We're trying to intersect the three tables together, right? So inventory, scan, cost. What we need to do is we need to pick up the actual serial number column of that inventory table because we're actually going to intersect specific columns of the data set. And let's do it again, distinct of scan inventory. We can see we've intersected 25 rows. So what that tells us is that there's a pretty good match between the scan and the inventory. So now we want to intersect this with cost, right? Let's do another intersection. And so we have our left-handed table, which is the intersection of our inventory and scan. So now we're going to do a distinct of our cost serial numbers and run that. So you can see we have 24 rows net. So now we're going to take this, we're going to copy it. We'll locate this in the measure table, right? So we know this table works. We're going to use a counting iterator that will go down that table incrementally. And so now we need an expression. And recall we had our explicit number here. So we have no errors in that formula. So what we have is our measure computed on the fly is the same as our measure that we've done previously. Okay, first some history. When we first started this a couple of years ago, we basically arrived at our values by inserting slicers and picking up the gaps that accrued with the slicers. It was difficult because we had no way to scale into different scenarios, and we'll talk about that in a minute. But let's go through a quick example here. We would say, gee, we want to see what's in cost, but we want to see the gaps that are in inventory. So we want to pick up the blanks in inventory and the blanks in the scan. So what we're able to say now is with great certainty, we see these serial numbers in cost, we don't see them in the source, and we don't see them in the scan. And so we have three numbers here that are available at about $57,000. And we were able to understand a piece of what we wanted to accomplish. Now, to the extent that we had different scenarios, we had to accumulate those values incrementally. So let's, as an example, you can see we've got a particular scenario here, and this is ginned up from a previous video, where we're looking at non-billable sites. So we would pick up non-billable sites. But the very next scenario has got billable sites with deleted assets. And so you cannot accomplish the accumulation of those two measures with one set of filters. They're mutually exclusive. And so every time you've got a set of mutually exclusive conditions associated with filters, you've got to stop and you've got to sequence the aggregation of those values. You can't do it in one pass. By contrast, you can do it easily with measure. And we have a particular measure here that is called CapEx missing. And you can see our CapEx missing totals 83,000. That's a combination. It's a combination of what we observed before plus the missing CapEx from another environment. So let's go through that. We'll get to the CapEx missing function in a second, but before we do that, you can see what we have here is an implied calculate statement. It's basically dragging on this measure here to be incorporated into the CapEx missing piece. We'll gin up a new value here. We can't really use DAX for this. We'll have to sort of wing this one real time. We want to create a new measure 3. Okay, so what we're saying here is we'll take the sum x because we're going to aggregate row by row, right? And we want to aggregate through the index table. So now we want to construct our expression. We simply replicate the expression that we developed for the calculated column, right? So we're saying if the INDX source is equal to cost, that's the test. Then what do we want to do? We want to calculate the sum of our CapEx. Okay, we don't need a filter on that. calculate, close out the if, close out the sum x, and let's check that. And so that formula should work. Let's measure 3. We can see our measure on the fly basically replicated what we had before, which is good. So let's get rid of it. Now we're going to jump to DAX, and we're going to describe our CapEx missing formula. Okay, so here what we're trying to accomplish is we want to develop an exception. We want to start with the core of the function, which is an except. And you can see what's going to occur here, right? We want to take the left-hand side, which do not appear on the right-hand side. It means that we want to take the values in cost, and we're going to, on the left-hand side, and subtract out the right-hand side. So let's take the distinct, and we're going to take the cost. That's the left-hand side, and we're going to take the distinct, and let's run that. We have 5 numbers here that are showing up in cost, but are not showing up in the inventory side. So we're taking the distinct of the serial numbers on one side, we're subtracting out the right-hand side, and what we're left with is the residual. Now we can build a real function on this. We have our table. Let's copy it, go back into our measure box. We're going to strike measure 4. So we know the table works. We know this will give us the right numbers. And so what are we going to do? Well, we want to aggregate again, iteratively, all the way down that table, that big index table. But we want to have a subtable here, which is only the missing one. And now we want our CapEx that we had, that we ginned up. Here's our CapEx value. Apply calculate. We close that out. That works. So this is measure 4. And you can see that measure 4 that we created on the fly basically is consistent with what was developed previously. You can see what we have here is a combination of some very powerful tools, right, which is the application of measures that we're constructing on the fly that are resident inside the measure table as opposed to calculated columns, and then the use of advanced set theory, and we're able to concatenate these two and come up with missing CapEx. You can see here, I did this in a previous video, we have 5 or 6 separate scenarios that we can accumulate simply by adding up the savings of those individual items. And now we can work with an aggregated set of dollars for multiple scenarios aggregated into a single measure, simply by adding all these things up. You'd want to see where the savings are coming from, right, by region or by site code, and you'd want to look at all the savings aggregated, sliced by different dimension categories, which is very powerful and not something that is doable with filter. Okay, so let's now go to our Power BI, bring up our solution. Okay, so we've opened to the visuals page. I mean, we have all these different measures that correspond to what's being represented here. So when you click this, you can see the gap has narrowed. So that's the point of the intersection. You can see if I want to focus here just on where we should be applying our effort. Clearly, the biggest gap exists between the cost and the inventory, and simply clicking that, you can see the jump in there. Okay, so that's a little bit about the sliceability of the visuals. I want to now move to the phone layout. You can see here. This is a representation of the phone. We have our visuals here that are carried forward, and it's great. We simply bring them to our slide area here on the phone, and they'll situate themselves, and we have something that looks reasonable, and stick it here, and we are good to go. Let's go back now to and we publish it to our Power BI service. Okay, you can see here the visuals that we just worked on. They're sliceable in the Power BI service. They're exportable and publishable to the web through various export features here. For example, publish to the web will yield an embed code, and we can either send the code in email, or we can embed it to a site and publish the views that way. Okay. The other option, of course, is to share. That does require a upgrade to Power BI Pro. And so this is basically exportable directly to individuals with an upgrade in the credentials. Okay, so that's the Power BI service. Okay, let's now go back to our lesson plan objectives. Okay, just to recap where we let off, successful in talking about the multiple fact tables presenting data sets. We talked about the primary transformations that generate the index table. The queries needed to make that happen in the M code. We saw the data model was linked together. We talked, quite a bit about why measures instead of calculated columns net bigger, faster models. We looked at DAX expressions and we constructed some expressions with new table functions using set theory. And we talked about filter expressions being created with virtual subtables. Implicit calculate and the sumx, countx, we talked about that. And of course, Power BI, not really evident in this one, but I do have another visual out there that describes why Power BI scales so much more effectively than the standard Power Pivot. Essentially, we're talking about orders of magnitude improvements in response time because of caching capability that's built into the background. So clearly, it is the BI tool of choice for individuals interested in deployment of actionable insight through interesting visuals. Thank you very much. Please call if there are any questions or comments. Bye-bye.